Hello everyone. Thank you for joining this modern Rigid-Flex design in Altium Designer webinar. My name is Priyankar Ghosh. I am working as a field application engineer in VVDN Technologies for Altium Designer. So for upcoming webinars, please do visit our websites www.altiumvvdntools.com. Under events, you can see our upcoming webinars. And we are happy to announce that we are on social media platform named as VVDN Tools. So we are keep posting our webinar details and more information. So you can get notified on this. And we are uploading our webinar recordings over YouTube channel. So you can subscribe our YouTube channel and you can get our recordings. So today's agenda for this webinar is Rigid-Flex design overview, challenges of Rigid-Flex PCB design, advantages of Altium Rigid-Flex features, then modern Rigid-Flex substrates means materials, then fabrication documentation, live demonstration, and Q&A session. Rigid-Flex design, it's a printed circuit board with combination of both flexible circuit as well as rigid circuits. So PCB design within both rigid and flex options are available. So it's mechanically support and electrically connect with electronic components with copper traces, and it's on a flexible non-conductive file also there. Next, challenges of Rigid-Flex PCB design. Why Rigid-Flex PCB design and what are challenges are there? So basically, we can fit multiple PCBs and we can associate and interconnects within small challenging form factors. Okay, and we can reduce the weight of your end product, and it's very much helpful for us, and for better protective it also we can use, and we can use it for surgical industry also, surgery industry also, and we can implement a continuous movement with interconnected, and we can reduce our board size and interconnect with assembly cost also we can reduce. Then we can improve the quality and reliability of the board interconnect, and we can improve managed heat dissipation also. So why Rigid-Flex PCB designs are there? So packaging issue. If you are facing any packaging issue for a small farm or factory, or a space constant is there, so that time we can reduce this one. And up to 60% space or weight we can saving through this Rigid-Flex designs. Like we can smartwatch we can build and all, just for example. So that time we can use this Rigid-Flex design. And for space constant also there, suppose 60% space and weight saving by eliminating wires or harness or solder, we can do this one. And for anesthetic purpose also we can use this Rigid-Flex, like for surgical device we can use, and had a wire harness connecting to two circuits, and replace with a flex section, as well as patient satisfactory improvement also there. Then products with moving parts, like a laptop screen or folding device. So that time also we can use this Rigid-Flex design, and it is simplest, helpful, and more durable and reliable, and it's a more functional also. And with the low cost, we can develop our product. So assembly cost also reduce with this design. Okay, and we can reduce the number of connectors and a substrate also, so automatically assembly cost will reduce, and quality also we can build. So flex circuits are extremely durable, and it can be bent also, right, and folded, so tens or hundreds of thousands times, where hardness may fail. So also the assembly elements the potential human task wire and connected assembly may require. So that time we can use this design. And power distribution and high heat. So that time also flex portion is dissipate with heat for efficient than typically substrate, and beneficial for high power application. So that time we can choose our material substrate and we can use it. Summary for these challenges, like how much will it cost to fabricate and assemble for Rigid-Flex? Then how are like it's a low cost for fabricate and assembly purpose we can use. Then how are dissimilar rigid and flex section and describe as one PCB assembly. So this one we can do our Altium Designer software. So both supports are there. Then how are different rigid and flex materials? So for rigid and flex materials are different, we can use our different substrate or dielectric materials. Then layer specification and everything we can manage over Altium Designer. And how we can range the motion and critical folded states be modeled and verified. So both are verified and we can check. Then how's the placement and routing, those things will show during the demo session. Advantages of Altium Rigid-Flex features. So Altium Designer, as you know, it's a unified platform, and it's a address many changes when designing Rigid-Flex PCB, because it offers a complete solution. Okay. So within Altium Designer tool, we can do Rigid-Flex design functionality, then coordinates with layer stack manager, and we can define our layer stack, and we can select materials, and directly to BOM also we can generate. So coordinates with our industry leading 3D engine, so we can view our 3D view also for our design. Then so both we can see rigid and flex folded bends and measurement, everything we can do, and we can collaborate with MCAT team. So mechanical support also there, so both we can see. Then advanced constant management is there. Okay, so for that rigid and flex we can define different kind of design rules, constraints, and we can use it. And multi-board support is there. Okay, so two board easily we can connect with connectors. Okay, so those kind of advantage is there. Then another advantage of Altium Rigid-Flex features is easily we can define. Here you can see different layer stack. So here you can see one option will be there, features under feature Rigid-Flex. First we have to enable that one under Altium Designer. Then here it will come plus bottom is there. So first you can click that one, then we can open our properties window, and from our properties window we have to enable this flex option, and we can rename our stack name also. Once it's done, then here you can see under we can choose layer type. Okay, and under that dielectric or substrate we can change. Here you can see three dot is there, so from there you can click and you can select your material. So once it's selected, then you can go for plus button, and you can add another flex or rigid layer stack also. After that you have to enable this layer. Okay, and you can save your uh, layer stack. So like that we have to choose and dimension everything we can provide under this window. And another advantage is there, like we can directly import DXF file or DWG file or step file. Okay, and if you import a DXF file or DWG file, so we can create our board outline. Here you can see, once you provide the board outline, then we can create your board from the defined board shape, and we can move to our board plan view, and we can define split lines from rigid and flex region. Once you define the split lines, then we can define bending line and bending radius also we can provide for each flex region. After that we can verify the bending and fault state sequence. Once it's done, then we can move to our 3D view, and we can verify the range of bending through the entire folded state. So here you can see the short video on this. So like this complete product we can develop through Altium Designer. So as we mentioned, advanced constant manager is there. So through that we can use our constants manager, and we can define rules for that. Okay, and we have multi-board support also, so we can add 2 3 board, motherboard, daughter board we can connect through this. So modern rigid flex substrate. So as we mentioned, we have material library for substrate also. So from the material library we can choose available materials only, and if it is not present, so customize material also we can add. Okay, so there is under 8020 material library, pre-peg, course, sieve foils, solder mask, coverless, everything is there. So we can choose and define our materials. And here you can see what types of materials are available and which should I pick. Okay, so if you open Altium material library, so under that surface cover lay, then signal layer copper, then dielectric, under dielectric polyimide and polyester. So those materials are available, so you can go through and you can choose from there, and we can load also material libraries. Documentation, so we can create a fabrication documentation also for this. So for all drawing, like board outline with dimension, then drill map, drill legend for quality checks, then critical information we can provide, which and then all board component data or indication for manufacturing to use their standard. So those things we can provide. Then for flex specific drawings, like static or dynamic application type, then material and layer stack up, we can define dimension and location for all rigid flex region we can provide. Then location where the flex will be bent to that degree, uh, rotation. So everything we can provide under our fabrication documentation, that is called Trapman documentation. So we can provide and we can share it with our fabrication house. Let's move to live demo. Hope you were able to see Altium Designer window.
Yes.
Okay, so here you can see, let me open one example project first. So this is the 3D view, and we can move to first board plan view. So under main menu, view option is there. So from there you can go to board planning mode. Its shortcut is 1. You can select this and move to board planning mode view, and here you can see we have defined layer stack region. Okay, so different layer stack region is there, like board layer stack, flex, mid. Okay, so this kind of layer stack we have defined. So what we have to do, first we have to provide this, go to design and define first split line. Okay, so where it will bend. Okay, so for layer stack, to set the layer stack, first we have to define our split line. Okay, once you provide this split line, then you can provide define bend line. Okay, then go to layer stack manager, and under layer stack manager we can create our layer stack for uh, rigid as well as flex. So here you can see one feature option is there, so you can click on the drop box and we can enable this rigid flex feature. Okay, once you enabled, so after that under stack up window, here you can see for board stack is there. So here another two layer stack also is there, so we have to add. So there you can see plus button. If you click plus button, so we can add substack. Okay, so it's already available, so from there you can select. Okay, so from there you can select and you can enable, and here you can see we have materials also for this dielectric and all. We can choose Altium material library. Okay, so if you click on the three dot, so from there we can load our material library. Once you clear, so after that you can select the material. Okay, so here type is there code, so from there we can choose code or prepeg. Okay, so each and everything, manufacturer name, thickness, constructions, resign frequency, those details is provided, and from there you can check and you can choose your material. So this one is there. Apart from here you can see, if you go to tools option, then under tool option material library is there. So from there also we can select. So if you go for surface finish or foil, okay, then dielectric layer material like core or prepeg, surface layer material, flex cover layer, solder mask, so everything we can mm, go for it, and you can select the material. Okay, and apart from that we can load also. Suppose you want to use a different materials, so from there also we can load your own material library. Okay, so those things we can choose, and from there we can change the setting also. Okay, so what kind of column you want to view, so those you can enable disable. Okay, so this is there, and under tools here you can see layer stack visualer. So from there also we can view the layer. So like that. This is the 2D view. From there we can select 3D view also. Okay, so from there we can view layer stack. So once this is selected, and here you can see we can change the type also. Suppose if you want to use bikini overlay, so that also we can use. And if you want to add, so you can select and insert above or insert below. Okay, so like that we can choose and we can use. So this option will enable, so you can use signal layer or plane layer, then code or prepack dielectric surface finish, then solder marks or bikini overlay. So those things we have add. Okay, and if you go to view panels, then properties, so from there you can if you want to choose stack symmetry, so that's all, so you can enable and you can disable it. So if you, so these settings you can do. So this stack application you have to do. Once this done, then move to your display layout and go to board plan view, and you have to click this one and you have to choose the layer stack. Okay, so whatever layer stack we have created, substack also, both will show here. So from there you can choose. Okay, and we can define. If you want to lock any 3D lock, so that also you can enable from here. Okay, and if you want to change the name, so you can rename also. Once this is done, then from there we can provide a radius angle. Okay, if you click on this, so bending angle 180 degree or 270 degree or 90 degree, like that angle we can provide. Then radius. Okay, then affected area width, both we can provide, and fault index, so number we can, means ki sequence we can provide. Okay, so let me move to 3D view. Okay, so once it's done, then go to your view option, then panels, properties, sorry, view, panel, PCB. So under PCB you have to select layer stack region. Okay, so if you select layer stack region, so all the available layer will show. Okay, here you can see all the available layers. So from there, if you want to change or if you want to lock, so from there we can do. And here you can choose sequence also. Okay, so if you select this one, then go for it. So here is sequence is 0, then 1, 2, like that sequence we can set. So sequence means ki one by one this portion will fold during the 3D view. Okay, sequence 2, sequence 3, 1, like that we can provide. Once then done, so now we can see. So like that sequence wise it is bending. Okay, so like that we can view our design. So this kind of design, rigid plate design, we can do our Altium designer, and for this we can provide documentation also to our fabrication house. Okay, so for that you have to select our project, then add to new project, draftment documentation. Okay, so through documentation we can provide everything. Yeah, so there is, you can see place option is there. So from the place option we can provide board assembly view, so it will retrieve data and each and everything, like board view, then board information, fabrication view, then dimension, each and everything we can provide through our draftment documentation. Okay, view from top side, this one, if you double click this one, properties window will be open, and from there we can change the view side also, top view, then bottom view. Okay, so like that we can change the view position, then dimension also, each and everything we can provide, place, linear dimension. Okay, so dimension and all we can provide. Then here you can see board sectional view, then layer stack legend, layer stack information also we can provide. Okay, then right click, add new sheet, place, fabrication view we can provide. Then another the advantage is we can provide our uh, board realistic view also. Okay, so what is a realistic view? So that also we can provide. And suppose you any sectional position also, means ki custom position also we can provide. Okay, so suppose from this side, to view panel PCB, let me fold this one. So this kind of view for camera position also we can provide. Okay, then go to document documentation, double click, and from there we can choose custom and select take current camera position. Okay, so this kind of realistic view also we can provide, and we can place here, you can see drill table, transmission line, bill of materials. Okay, so those information also we can provide. So let me show you one example, one demo project. Okay, so it will be more clear. Go to file, new, create project. Just provide project name, then provide a path, then create. So once it's create, then you can add schematic and PCB. Let me create PCB. So this is the default board, so we can import our DXF file also, as I mentioned. File, import DXF or DWG file. So here you can see extension is there, .dxf. We can open. So that time it will choose the unit. Okay, so that you can choose and click OK. So here you can see DXF file is imported. So you can choose this one, click tab. So board outline will choose, and then go to design, board shape, define from selected object. Okay. So mechanical people will share this DXF file and we can import directly. Once it's done, so just for example, I'm placing one component, just hit at 6. Shift plus spacebar to rotate. Once you placed, then after that, after placement and all, before that, we can provide layer stack manager. Okay, click on the layer stack manager, then from there, here you can see features option. Click on that and enable this rigid flex option, then click plus button to add substack. Okay, so here you can see this name and go to view panel properties. From there we can change the name. Okay, so it will be for flex design, so we can enable this option. Once it's done, so you can save, or as I told you, we can choose our material also, material library, if you want to change. So that also we can choose from there. Okay, so once it's done, then you can save, move to your PCB design. Okay, go for board planning view, then here we can define from the design option split line. You can define the split line. Okay, so once it's done, so you can click like that and we can choose the which one will be for a rigid and which one is flex. Okay, so that stack you can use So I'll choose this one for flex stack. Okay, then click OK. Once it's done, then we can design, then provide bending line. Okay, this bending line we can provide, and if you click this bending line, so from there we can provide bending angle like 180-degree, radius or affected area. Okay, so like that we can choose and click OK. Once it's done, verify this one, then go to PCB and select layer stack region, and from there you can see what kind of stack up is there. Okay, and layer information. Then you can move to 3D view. This one is board stack up and all. This one is for board layer stack. This one is flex. Okay, flex view properties. Sorry. Its place is selected. Save this one. Panel properties. It is an on flex.
Hello, Priyankar.
Yes.
Bro, actually, that rigid one, for rigid one, you have to lock the 3D. Only
Okay.
then,
Yeah. So we have to lock this one.
yes.
Then we can move to 3D view, and here you can see it's bending. Okay. So this board we have to lock. So after that we can move and it will bend like this. Okay. So from there also you can view. Okay. So this kind of flexible design we can do. And for routing also we can do for this design, like for that we have to we can design our rules. Okay, so here you can see port outline clearance, so we can create new rule. Okay, and we can provide minimum clearance. Click OK. So once you provide this rules and all clearance rule, so after that we can do routing also for this one. Suppose just for example I'm choosing this one. Okay, then we can move, and here you can see cutout. So for this we can use follow mode also. Okay, shift plus F. So if you click here, you can see this kind of follow mode also we can use for our design. So we can use follow mode for this kind of design. And we can do our routing for this. Okay, so this kind of follow mode also we can use in our design. Okay, so make sure you have selected this 3D lock option. Okay, so for that we have to go to board plan view, then select, and we can lock the 3D lock. Okay, so this option is there, and you can provide this documentation also to your fabrication house. Okay, so thank you for your time and attention. So if you have any questions, so you can unmute yourself and you can ask, and you can directly contact us for Altium Designer